one, we're going to find a formula for the general term a sub n of the sequence, assuming that the pattern of the first few terms continues. So just looking at these three, I notice that if I take this and multiply it by 2 for my numerator, I'm going to get 8. And if I multiply my 8 by 2, I get 16. And then for the denominator, I keep multiplying by 3. I also have these alternating signs, so I'll put a negative. So negative 2 times negative 4 is 8, and so forth. All right, so that seems to be our common ratio. Again, I'm not looking at these yet. If you look at the 2, I can write this as 2 divided by 3 to the 0 power. In this case, this would be negative 4 divided by 3 to the first power, 8 divided by 3 squared, and negative 16 divided by 3 cubed. So this works out fine. We're going to write n minus 1 here. And since it has a common ratio, I'm going to write my negative 3 as my first term. So this is going to be your nth term, or your explicit formula. And I'll write it here. And especially in a problem like this, it's probably a good idea to check it to see if it works. So writing this out, I kind of have it lopsided here. But if you take any one of these terms, we have 5. Look at, let's say, the third term. So let's plug in 3 for n. So I have a of 3 equals negative 3 times negative 2/3 to the 3 minus 1 power. This gives me negative 3 and negative 2. This is going to be squared. It's going to be 4. And then 3 squared is 9. And then negative 3 goes into 9 negative 3 times. So those cancel out and you get negative 4/3. And that's what we have. And then you can test any of these. Let's test the first term because that's the one that looks kind of off the pattern. So we can write a sub 1, because that's our first term, equals, and I'm following this formula, or it looks a little better here, equals negative 3 times negative 2/3 to the power of 1 minus 1. Well, anything to the power of, this is 0, is 1. So we're left with negative 3. So our formula works, and we're good to go. Thank you. Have a nice day. Bye-bye.